Hello. In this video, we're going to share with you our previous colleagues' work, which has some very interesting coincidental connections for the duality in the linear programming, which is called HEC-based data forwarding in opportunistic works. We were just trying to skip the detail part. If you're interested, you can check the following names: Dr. Chen, Mr. Zhang, and also Dr. Zhou. They have developed this for opportunistic networking applications, which has been used for sensor-based network communications underwater. And also some messages like routing messages like message fairings, profit or epidemic routing has been developed from Duke University and also Seneca NRL and so on. And they try to track the mobility pattern-based scheme for that. But in this paper, the major contributions of that, besides the previously pre-processing steps of that, I think the most exciting part of this is about erasure coding, aggressive erasure coding, and also hybrid erasure coding, and also all those part of network coding. Because the contact is very precious. You cannot just contact them and talk with them very frequently. So that's why they have to take good advantage of the use of the contact. And what will be their contributions of that? Uh, we were just basically introducing the simple concept. Suppose we have four different messages that needs to be delivered, A, B, C, D. Is it possible? It is possible that we can just produce four copies of that individually. But even after that, because the channel is lost, the connection is not always like the cell phone or the internet. So it's lossy. That means that your message could hardly be delivered completely. So that means afterwards, what will become? If three copies of B, uh, the B sender and the B receiver pair has been delivered, then we will say, well, the B is safe. At least the message finally reached the destination. And for the A message is also very lucky because all four copies of that has been produced. But for the message C, only two of them has been delivered, but still lucky enough to deliver that. But for the message D, because there's only one copy, so as long as there do exist some uh, unimaginable accidental events, then the message is lost. If it's precious, if you watch the movie Passengers, if that message is important, like you have to deliver and receive the email back within like 90 years or 55 years to make sure that your message has been delivered to the centralized stations of the developers of the spacecraft. Then that would be the issues of that. Now we are trying to comparison the philosophy of EC and AEC and also the hybrid of HEC. So what does that EC and AEC means? If they do exist the philosophy of EC, that means once we have a contact 1, 2, 3, 4, and we have produced that four copy of that, one of that you can just to make sure that the first contact they do only exist. Uh, if, you can just pile up because if you have a full message, you can just put four copies of the messages to the first contact as long as the first contact is some way. But that means you just trying to ask the first carriers to put the major capability and the responsibility of that. But for the contact too, because the contact is short, so if that happens, then you only have some chance to get one copy. So if there do exist higher time slots of interval contact 1, a smaller slot of contact 2, and a little bit longer of contact 3, and even longer for the contact 4, then for the EC scheme, it should be like you have sent A1, A2, A3, A4, B1, B2, B3, B4, C1, C2, C3, C4, and D1, D2, D3, D4, etc. That's what the easy part has been used for. So that means you just do that sequentially, like by row. But for the AC part, you do the row and the columns of mixings of that. What does that mean? That means like this. You can do okay, for the easy part, it should be A1, B1, C1, D1, then A2, B2, C2, D2, then A3, B3, C3, D3, and then A4, B4, C4, D4. That's what the part of the EC and AEC has been described. So you can think of that like linear programming. You have a row part of sequencing of the sending messages, but also there's a column part of the messages of sending, just in case that you trust whether you're trying to ask one person who's responsible for that, or for sending the message as much effort as possible, or you're trying to take treasure of every contact and trying to distribute it as quickly as possible. But for this HEC that I have in this paper, they're trying to do the hybrid of that. That means for the first message, they use A1, A2, A3, A4, the 4 copies for the first contact. But for the rest of the part, they do a little bit mixed. They do the same sequentially for B1, B2, B3, B4, and C1, C2, C3, and C4 and D1, D2, D3. That means there's a mix of the duality for this application, the sending of messages. And how come they thought of that? I believe that they have tried different approaches in combinations of that, and found that this one might work for better for the trace of that file, because they do exist from the there do exist a website called like Quodat. Yes, we leave a lot of data sets, like the trace routes in UCSD and so on, in UMass. Um, I think the other contributions of that is for the delivery probability. They're also trying to measure the delivery probabilities of that. And they found that after the combination of this, in this determinist, sorry, in this DTN delay tolerant networks, uh, based on the Java-based DTN simulation, and also the record that has been checked from the ZBarNet that we have mentioned from the Quodat website, and also the iMode. Uh, I think they do exist some current versions of iMode, like called Raspberry, that has been promoted to Europe right now, and also some PDA combined with Wi-Fi for this trackings of wireless messages that has been traced in UCSD. So they have analyzed this and comparing them for the EC, HEC, and HEC PF, and how that can be combined for that. So that's what it is. The interesting part is that if you are interested in the perfect combinations of theoretical part of duality, linear programming part, and also the planar graph part of the duality part. In this part, in the real networking examples, they're trying to do a little bit tuning of that, because the duality method has been proposed by sending a message, because you can send a message as many copies as possible. You can send a message as individual as possible, just in case that you want your receiver to receive it. Because if you have production replications of the copies of the files, then for those senders who just carry too many copies, maybe you just consume its power. So that's what it is. But you can find that their method has been improved for this mixed strategy. But the interesting part is that we don't know in the theoretical part, is there any really this mixed part that can be interpreted from the duality in linear programming? So if you really know relative interesting concept, uh, how to describe that, then you can contact us. Yeah, thanks for listening to this video. And if you are interested in the UCSD scenario and the ZebraNet. I think there might be some typo. And also how they try to use this contact of cell phones due to the parallel distribution. That is the small world phenomena, the real-time small world phenomena that has been applied for computer scientists. You can check the NIL library from IS. Thanks. This is Dimitri from Algorithmic Research Incorporation. Thanks for listening. Bye bye.